by the theory. Okay? It's deductive reasoning. So for Popper, scientists have to focus on the attempt to falsify theories. They have to make conjectures like special relativity, general relativity, quantum mechanics. They can use induction to make these conjectures. They can use the psychology, they can use whatever, they can dream about it, doesn't matter. It's the context of discovery, of invention. That's not rational. That doesn't have to be rational. We don't ask whether Einstein, rationally came with, he may have dreamt about the special theory of relativity. That doesn't mean that it's not a good theory. If it's good theory, we judge according to the test that we give to theory. And that's the attempt to falsify the theory. So according to Popper, scientists should come up with as many informative conjecture theories and try to falsify them. Okay? And so scientists should try, to come with the most informative, to put this conjecture, to test, and the most severe test should be intellectually honest, even if they came up with the theory, and even if they get Nobel Prize for that, they should try to falsify it. That's intellectually right thing to do and rational, to not to think, I got a lot of credit for that, I don't want to undermine it. That's not rational. It could be psychologically normal, but not rationally according to Popper. And then those that are falsified, to throw them away, and to try to continue, to falsify the other ones. That's called conjectures and refutation. That's the name of Popper's philosophy. Well, that's one of the titles. So scientists try to make, to come up with as many conjectures as possible. The more informative, the better, and then try to falsify them. And as we shall see, what is knowledge according to? So we don't try to show that our theories are true, but we try to falsify them. And then the theories that remain are the provisional basis for knowledge. They're provisional because we try to falsify them. We might falsify them in the future. As the history of science shows, we did falsify. A lot of theories were falsified or have been falsified. So that's a book. He has a book that is called Projector. Okay. So let's see why, a little bit in more detail, why confirmation is inductive reasoning. By now, you should be familiar with that, but just to kind of, and then why deductive reasoning seems to be, why falsification seems to be deductive reasoning. So, as we said, in confirmation, how do we confirm theories? We look at them. We try to derive from them predictions, like special relativity. We try to derive some prediction of general relativity, and then we test this prediction, and we see whether they pass the test. If they pass the test, then it confirms it a little bit. If they pass the number of tests, then at some point we infer deductively that the theory is confirmed, more confirmed, less confirmed, depending on the test and depending on the variety and so on. So basically what we do, we say confirmation of theory T by observation 1, 2, 3, which are obtained in experiment 1, 2, 3, may be characterized as the following inductive reasoning. If T is true, we derive that observation 1 is true. We test, we do experiment for observation 1. We find observation 1, fine. We do test 2, we derive another prediction, observation, O2, whatever it is, and we find it true, and then we do experiment, we find it true, and etc. And then at some point we say the theory is true. Or maybe you want to say the theory is very likely true. That's a deductive reason. We do it all the time. That's the reason why we do experiments. No? So Popper said this is not good. What we did so far, what scientists do, we shouldn't actually focus on it. So let's see an example. Okay? So suppose that we think about the mosquito population in Toronto in the summer. And we see that it increases. We have like two hypotheses. One, so to show that induction, can lead to wrong, answer or it's. So for instance, we have one hypothesis that it changes linearly. 1 year is 1 billion, and then it changes like it grows linearly, and the other one it grows non-linearly. This is H2. And the observation is that we have 1 million mosquito the first year, 2 million the second, and third year we have 3 million. So in that case, we can do induction. And we actually can see that induction could support both hypotheses. No? But it may be in the future, for instance, that we find that that this goes up. And actually, if we find in the fourth year that there is 4 million and 4 million mosquitoes agree with H1 but not with H2, then we confirm more H1 but falsify H2. Okay? That's what we do basically. Okay. So let's see very quickly what is falsification. So Popper thinks that falsification is a deductive valid argument, and as we shall see, we think that it's modus tollens. So basically, what we do in falsification, we have a theory, we derive an observation, we test the observation, we find that it's false, so we conclude that the theory is false. No? Good. So it's basically the following case. We say if the theory is true, the observation is true. The observation is not true, therefore the theory is not true. Remember this modus tollens? So, it's a deductive argument. Falsification is a deductive argument. Deduction is justified for Popper. You don't need, if you follow his philosophy, conjecture and refutation, one doesn't have to rely on induction. Popper makes a distinction, and that's actually a distinction that we will see next week, that is very popular and very influential in thinking about science, between the context of discovery of theories and the context of justification. Induction is the context of discovery. It's, according to Popper, and as we shall see, the whole school of thinking, the positivist, it's not a matter of reason. It's not something, it's okay to come up with theory as much as you like, as far as whatever way you like. The rational part of theories is actually the evaluation in whether they are good or not. For Popper, the evaluation is the attempt to falsify theories. Okay? So induction, we can still do induction, but it's not the rational part of science, according to him. It's more psychological. The rational part of science is the attempt to evaluate these theories and to give them either false or not false. So, for instance, we say H1 is true, there will be 3 million mosquitoes in Toronto in the third year, and we observe that there are 200 million, then the hypothesis is false. No? We don't need anymore. That's the end of the story. Okay? Is it clear the difference between falsification and confirmation? One is inductive reasoning, the other one is deductive reasoning for Popper. Good. So we will end up with this part. There will be some the critical part we will talk next week. So Popper, on the basis of what we say so far, here is Popper's philosophy of science. Distinction between science and pseudoscience. Science is falsifiable, but pseudoscience is not falsifiable. It's a very, very influential distinction. That's the reason why people will tell you we need experiments, we need, observation. If you have a theory that you cannot actually evaluate in experiments, it's not scientific. So Popper thought, for instance, that psychoanalysis is not scientific. Whatever experiment you come up with, whatever observation, they always find a solution to that. Always it agrees with psychoanalysis. So he thought that psychoanalysis is not a scientific theory. So the idea that what is scientific is falsifiable, you can make an experiment and possibly find that it's wrong, that theory is wrong, that's very much, influenced by this idea. So everything that is not falsifiable, it could be interesting, psychoanalysis could be interesting, the believing God could be interesting, but it's not science. Because it cannot be falsified. If you believe that it cannot be falsified, some people think that you can prove from the hypothesis, but if you think that there is no experiment that you can show that, then it's not science. It could be interesting, but it's not science. What is the scientific methodology? Science progresses by conjecture and refutation. Scientists try to make more and more conjectures. They come with theories and hypotheses that they generalize, and they try to show them, they try to falsify them. They falsify them. Those that are falsified are thrown to the bin of history, the bin false, and then we continue with what we have. Scientists should make conjecture and try to refute them by subjecting them to severe tests. So they have to try to subject them to as serious as possible tests, and variable, and so on. And theories that are falsified should be rejected, and the theories that have not been refuted or falsified are subjected to more severe tests, and they may be falsified in the future. And knowledge, as we shall see, it's this provisional conjecture that have not been falsified so far. Now, Popper makes a distinction between corroboration and confirmation. Confirmation, we saw, is inductive reasoning. When you say that the theory is confirmed, it has implication for expectation for the future. So, theory that, but Popper says that theory that past severe tests are corroborated, not confirmed. Corroboration is not inductive reasoning according to Popper. Corroboration is not the same as confirmation. The difference between corroboration and confirmation is corroboration only have the information of which theory passed, what kind of test they passed. It's an index, if you like, of past performance without expectation for the future. Okay? To say that the theory is very corroborated is to say it passed a lot of difficult tests, severe tests, but without the expectation or that it's true, without the belief that it's likely to be true or true. Okay? That's the difference between confirmation and corroboration. Confirmation has implication that this theory is likely to be true. or is true, and so on. Cooperation is not. Okay? So confirmation is inductive reasoning, cooperation is deductive reasoning. Cooperation is just, if you think about it, you got like good grades in school. That's cooperation of your performance. You know, they were difficult courses, you got all A's. You are cooperated according to Popper. But not confirmed in the sense that you shouldn't actually expect such a student to do well in college. That would be induction, and induction is not justified. So induction would be to infer that the student that did do very well in school, in a good school, difficult, subject, difficult test, and so on, to expect this student to do well in school, like we do at U of T when we admit students, this is confirmation. This is an inductive reasoning. Popper says that scientists should not do that by reason. By reason, they should only cooperation, should only have the list of the performance, the index of past performance, without expecting for the future. We do it psychologically, you would admit, but this is not the rational part of reasoning. Okay, so we will continue next time. We will need another 25 minutes. But next time we will talk about Kuhn. Kuhn, we already one chapter of Kuhn. Again, Kuhn is not easy, but very important. So try to